In this video, we solve the numerical of Venturimeter. So first we understand the problem statement. A horizontal Venturimeter with inlet diameter 20 centimeter means one horizontal Venturimeter is given. Inlet diameter D1 is given 20 centimeter. Throat diameter 10 centimeter means D2 is given 10 centimeters. And it is used to measure the flow of oil of specific gravity 0.8. Means suppose here this Venturimeter is given and from this Venturimeter the oil is flowing, means inlet in this Venturimeter is the oil. Okay, so oil is flowing from this pipe and the Venturimeters, means in this manometer up to this distance there is oil is there, and this blue color part is the mercury, and this oil specific gravity is the 0.8, and the specific gravity of this mercury is the 13.6. Discharge of oil through Venturimeter is 60 liter per second. In the last numericals what we do, we are find out the Q, but in this case the Q is given, it is 60 liter per seconds, and we need to find the reading of oil mercury differential manometers. Means here we need to find out the X, means height between this oil level and this mercury, it is the X, and the CD is given 0.98. So first we note down this given data. First D1 is given 20 centimeters, that is the inlet diameter, and from this inlet diameter we are able to find out the inlet area. So A1 is equal to pi by 4 D1 square. So D1 is given 20. So area is equal to 314.16 centimeter square. Second thing is given the throat diameter D2. So D2 is 10 centimeters, and from the D2 we are able to find out the A2. So A2 is equal to pi by 4 D2 square, means pi by 4 into 10 square. So A2 is equal to 78.54 centimeter square. Other data is given the discharge of oil through Venturi, that is the Q, and it is a 60 liter per seconds, and we convert it in a centimeter cube per seconds by multiplying with this 100. So it is a 60,000 centimeter cube per seconds. CD is given 0.98, and we need to calculate the X. Now here the specific gravity of oil is given, that is 0.8, and we also know the specific gravity of the mercury as such is the 13.6. So first we need to find out the H by using this equation of the Q, because here the Q is given. We calculate the A1, A2 and the CD. So we are able to find out the H, and from this H we are able to find out the X. So first we note down this equation of the Q, and we already know how this equation is derived. If you don't know how this equation is derived, then I already uploaded this video and the link is given in the descriptions as well as in card, and this topic name is the Venturimeters. So Q is equal to CD into A1 into A2 into under root of 2GH divided by under root of A1 square minus A2 square. So first we put the value of Q, it is 60 into 1000, and the unit is centimeter cube per seconds, into CD, it is a 0.98. By mistake here the 0.98 is written, but it is considered as the 0.98. A1 is the 314.16, A2 78.54. So here we putting this value of A1 and A2 into under root of 2GH. So 2 into G. Now what is a G? G is the gravitational force, and its value is 9.81 meter per second square. But here we putting this all the value in a centimeters. Okay, here we putting this Q in centimeter cube per seconds. Area is in centimeter squares. So here we need to convert this G also in a centimeter per second square. So here we need to multiply this value with 100. Then we get this answer of this G is the 981. So here we putting this value of G is the 981 into this H. So here we put all these values, so we are able to find out the H. Okay, so further we simplified it. Okay, so here we multiply all these value, we get these answers. So here we multiplied all the values 0.98 into 314.16 into 78.54 into under root of 2 into 981. So we get this answer 1071068.78, and also calculate this value, we get this answer 304. Then further we calculate, means we supply this 304 on the left side, so it is going multiplications, this side is going the divide portions, and we get under root of H is equal to 17.029. Then after we do the square on both the sides, so here under root of H square is converted into the H, and square of 17.029 is the 289.98 centimeter of oils. So here we get this H in centimeters because we put all the values in centimeter squares, means area is putting in centimeter square, Q is putting in centimeter cube per seconds, G is putting in centimeter per second square. Okay, suppose we put all this value in a terms of meters, then here we get this answer in a meter of oils. Okay, now what is the equation of the H? Equation of the H is equal to X in bracket SH divided by SO minus 1. So here we putting the SH is equal to 13.6, means specific gravity of mercury, divided by specific gravity of oil, that is given 0.8, and X is indicate the reading of manometer that we need to find out. Okay, so here we putting this value of H, it is 289.98. we need to calculate this X. SH is equal to 13.6, SO is equal to 0.8 minus 1, and we simplified it, means this bracket is simplified, then we get this answer is the 16x. Okay, and this 16 is supplied onto the left side, means 289.98 divided by 16, then we get the answer of X is the 18.12 centimeter, means in a manometer difference between the level of oil and mercury is the 18.12 centimeters. So here we solve our numericals. So thank you for watching this video. If you learn something, then like the video and subscribe my channels for watching the more video related to FMHM as well as other subject of mechanical engineering. For FMHM subject, various link is provided in descriptions as well as in card. For other subject, I request to visit the playlist, and don't forget to share the channels with your friends.